Hello, so I'm just wrapping up the last part of the 2018 Oxford PAT. We've got two questions to go. Here's question 22. Determine the area inside the circle defined by this, but outside the triangle bounded by these three lines. All right, so what do we know about this circle then? Well, the centre of the circle is going to be at 4 minus 2, and the radius is going to be equal to the square root of 16 plus 4 minus 4, so the radius is 4. So we got that. Question is this triangle going to be completely inside the circle or not? Right, I think we're going to have to sketch some of these lines. So we've got y is x minus 7. Then we've got this one is also right, so we're erring towards positive x on here, so let's offset the axis a little bit. We're also erring towards negative y, so I'm going to really go in on that area. Although we've got, what did I say the centre was? Centre was 4 minus 2. Let's just write that again down here so I can actually see it. Centre 4 minus 2. So we're going to go up to plus 2 on that. But I'll draw the circle in after I've got the lines because I think that might be easier. So we got an x equals 7. Well, I'll put that in at the end then. So we got an y is x minus 7, looking something like that. Then we got an x is 7, which of course is going to be looking like that. And then we've got this y is a fifth of 2x minus 29. Right, so that's going through 5 and 4 fifths, minus 5 and 4 fifths. So around about here, say, at a pretty flat gradient. So something like that. So this is our triangle here. Okay, so what are all these points? Well, we know that this point, well, that's just at 7, 0. So where do these ones cross then? So when x is 7, we've got 14 minus 29 over 5. So that's going to be minus 3. So that's at 7 minus 3. These are crossing at, where are these going to cross? Well, they must cross. Actually, they don't have to cross there. So where are these things going to cross each other? There, which lines are these? That's these two. So if we've got 5x minus 35 is equal to that. So 3x is going to be equal to 6. So x is 2 minus 5 for y. So that's our coordinate points for those. So where's this circle is sitting at 4 minus 2. So, okay, somewhere around, I don't know, somewhere like there, maybe. It's going up to here. Is it going to enclose all of these points? That's what we want to know, isn't it? So is the distance from each one of these. So from 4 minus 2 to each one of these points. So we've got a 7, 0, a 7 minus 3, and a 2 minus 5. So we need the distance from the centre to each one of these to be less than 4. So we've got a 3 squared plus 2 squared is less than 16. So that's fine. We've got a 3 squared plus 1 squared is less than 16. And we've got a 2 squared plus 3 squared is less than 16. So therefore, we got the triangle inside the circle. So all we have to do then is say we got pi r squared, which is 16 pi, minus the area of the circle. And it's handy they've given us this straight line here, because the area of the circle is going to be half the base times the height. So that height there is, what's that, 5? Is that right? Yeah, 5. And then we've got half the base is 3 over 2. So we've got 7.5. There you go. That's that. That is the area of the circle minus the triangle. Right, that wasn't too bad. It would have been a real pain. I'm not sure we would have even been able to do it if they put the circle and the triangle sort of, overlapping. It's only partly inside the circle. Otherwise, that was not so bad, really. So, and again, noting the fact that you don't have to go through all the rigmarole of rearranging everything in order to see the centre and the radius of a circle. And the centre, you just got to halve the coefficients on x and y, and then you square each one of these, add them up, and take off the individual number that's left in that initial format of the circle. Square root that, and it gives you the radius. So, you keep repeating these steps, so at least spot the pattern and make it a little bit quicker if you need to. Right, so the last question, just for 5 marks. This is our f of x. Determine the range of x for which it's real and finite. Right. So if we want it to be real, then we need that x squared has got to be greater than or equal to 2. So that's one thing. That's for the numerator. For the denominator, well, we can't have negative inside, so we need that 3x has to be greater than minus 10. Well, we can't have 0 either. So that's for real. So we need that x is going to be greater than minus 10 over 3. We need to have, actually, could it be the same? Oh no, we can have, maybe we can have that equals in there. Because if you add, log of 0 is minus infinity. So yeah, that's going to be fine. If you put that at the bottom, it's still going to be real and finite. So yeah, let's stick that back in again. So we got greater than or equal to minus 10 over 3. And in this case, we've got that x is greater than or equal to root 2, or x is less than or equal to minus root 2. So that's done the real bit. So then for finite, we need that, we need to have that log 3x plus 10 is not equal to 0. So we need 3x plus 10 is not equal to 1, which means that x is not equal to minus 3. That's what we need on that. So we've got all of these conditions. So we've got that. So what does this mean then? We need that x has to be between minus root 2 and minus 10 over 3. Yeah, it's got them the right way round. Or we need x has to be greater than or equal to root 2. And we need that x is not equal to minus 3, because that is in that range. So, yeah, I suppose you could split that out again. I don't know whether it's best to write it like this, or, if you've written it as, well, it's greater than or equal to minus 10 over 3, but it's less than minus 3. And then it's got to be, was that greater than minus 3, but less than or equal to minus root 2. And then the other bit, whatever way round you want to write it. But anyway, I've got that as the final setup. So that was quite a nice finish. Those 2 questions were quite nice, actually. The last batch were pretty difficult, but those ones were much more intuitive, I think. They seemed a bit friendlier than the previous set of videos. So that brings the end of another paper. We haven't got very many to go. I think there's another 5 to get us up to date on all of these. So 2019 in the next one.